Aphorisms 11 to 12 of Book 2 of the New Organon. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The New Organon by Francis Bacon. Translated by James Spedding, Robert Leslie Ellis, and Douglas Denon Heath. Aphorisms 11 to 12 of Book 2. 11. The investigation of forms proceeds thus. A nature being given, we must first of all have a muster or presentation before the understanding of all known instances which agree in the same nature, though in substances the most unlike. And such collections must be made in the manner of a history, without premature speculation or any great amount of subtlety. For example, let the investigation be into the form of heat. Instances agreeing in the nature of heat. 1. The rays of the sun, especially in summer and at noon. 2. The rays of the sun reflected and condensed, as between mountains or on walls, and most of all in burning glasses and mirrors. 3. Fiery meteors. 4. Burning thunderbolts. 5. Eruptions of flame from the cavities of mountains. 6. All flame. 7. Ignited solids. 8. Natural warm baths. 9. Liquids boiling or heated. 10. Hot vapors and fumes, and the air itself, which conceives the most powerful and glowing heat if confined, as in reverberatory furnaces. 11. Certain seasons that are fine and cloudless by the constitution of the air itself, without regard to the time of year. 12. Air confined and underground in some caverns, especially in winter. 13. All viscous substances, as wool, skins of animals, and down of birds, have heat. 14. All bodies, whether solid or liquid, whether dense or rare, as the air itself is, held for a time near the fire. 15. Sparks struck from flint and steel by strong percussion. 16. All bodies rubbed violently, as stone, wood, cloth, etc., insomuch that poles and axles of wheels sometimes catch fire, and the way they kindled fire in the West Indies was by attrition. 17. Green and moist vegetables confined and bruised together, as roses packed in baskets, insomuch that hay, if damp, when stacked, often catches fire. 18. Quicklime sprinkled with water. 19. Iron when first dissolved by strong waters in glass, and that without being put near the fire, and in like manner tin, etc., but not with equal intensity. 20. Animals, especially and at all times internally, though in insects the heat is not perceptible to the touch by reason of the smallness of their size. 21. Horse dung and like excrements of animals, when fresh. 22. Strong oil of sulfur and of vitriol has the effect of heating in burning linen. 23. Oil of marjoram and similar oils have the effect of heat in burning the bones of the teeth. 24. Strong and well rectified spirit of wine has the effect of heat, insomuch that the white of an egg, being put into it, hardens and whitens almost as if it were boiled, and bread thrown in becomes dry and crusted like toast. 25. Aromatic and hot herbs, as dracunculus, nasturtium, vitis, etc., although not warm to the hand, either whole or in powder, yet to the tongue and palate, being a little masticated, they feel hot and burning. 26. Strong vinegar and all acids, on all parts of the body where there is no epidermis, as the eye, tongue, or any other part, when wounded and laid bare of the skin, produce a pain but little difference from that which is created by heat. 27. Even keen and intense cold produces a kind of sensation of burning. Nec bore penetribo frigus adruit, nor burns the sharp cold of the northern blast. 28. Other instances. 12. Secondly, we must make a presentation to the understanding of instances in which the given nature is wanting because the form, as stated above, ought no less to be absent when the given nature is absent, than present when it is present. But to note all these would be endless. The negatives should therefore be subjoined to the affirmatives, and the absence of the given nature inquired of in those subjects only that are most akin to the others in which it is present and forthcoming. This I call the table of deviation, or of absence in proximity. Instances in proximity where the nature of heat is absent. Answering to the first affirmative instance. 1. The rays of the moon and of stars and comets are not found to be hot to the touch. Indeed, the severest colds are observed to be at the full moons. The larger fixed stars, however, when passed or approached by the sun, are supposed to increase and give intensity to the heat of the sun, as is the case when the sun is in the sign Leo, and in the dog days. To the second. 2. The rays of the sun, in what is called the middle region of the air, do not give heat, for which there is commonly assigned not a bad reason, viz., that the region is neither near enough to the body of the sun, from which the rays emanate, nor to the earth, from which they are reflected. And this appears from the fact that on the tops of mountains, unless they are very high, there is perpetual snow. On the other hand, it has been observed that on the peak of Tenerife and among the Andes of Peru, the very tops of the mountains are free from snow, which lies only somewhat lower down. Moreover, the air itself at the very top is found to be by no means cold, and only rare and keen, insomuch that on the Andes it pricks and hurts the eyes by its excessive keenness, and also irritates the mouth of the stomach, producing vomiting. And it was observed by the ancients that on the top of Olympus the rarity of the air was such that those who ascended it had to carry sponges with them, dipped in vinegar and water, and to apply them from time to time to the mouth and nose, the air being from its rarity not sufficient to support respiration. And it was further stated that on this summit the air was so serene and so free from rain and snow and wind, that letters traced by the finger in the ashes of the sacrifices on the altar of Jupiter remain there still the next year without being at all disturbed. And at this day travelers ascending to the top of the peak of Tenerife make the ascent by night and not by day, and soon after the rising of the sun are warned and urged by their guides to come down without delay, on account of the danger they run lest the animal spirits should swoon and be suffocated by the territory of the air. To the second. 3. The reflection of the rays of the sun in regions near the polar circles is found to be very weak and ineffective in producing heat, insomuch that the Dutch, who wintered in Nova Zembla and expected their ship to be freed from the obstructions of the mass of ice which hemmed her in by the beginning of July, were disappointed in their expectation and obliged to take their boat. Thus the direct rays of the sun seem to have but little power even on the level ground, nor have the reflex much, unless they are multiplied and combined, which is the case when the sun tends more to the perpendicular. For then the incident rays make acute angles, so that the lines of the rays are nearer to each other. Whereas, on the contrary, when the sun shines very obliquely, the angles are very obtuse, and thus the lines of rays are at a greater distance from each other. Meanwhile, it should be observed that there may be many operations of the sun, and those too depending on the nature of heat, which are not proportioned to our touch, so that in respect to us their action does not go so far as to produce sensible warmth.
but in every respect to some other bodies they have the effect of heat.
4. Try the following experiment. Take a glass fashioned in the contrary manner to a common burning glass, and, placing it between your hand and the rays of the sun, observe whether it diminishes the heat of the sun, as a burning glass increases and strengthens it. For it is evident in the case of optical rays that according as the glass is made thicker or thinner in the middle as compared with the sides, so do the objects seen through it appear more spread or more contracted. Observe therefore whether the same is the case with heat. To the second. 5. Let the experiment be carefully tried, whether by means of the most powerful and best constructed burning glasses the rays of the moon can be so caught and collected as to produce even the last degree of warmth. But should this degree of warmth prove too subtle and weak to be perceived and apprehended by the touch, recourse must be had to those glasses which indicate the state of the atmosphere in respect to heat and cold. Thus let the rays of the moon fall through a burning glass on the top of a glass of this kind, and then observe whether there ensues a sinking of the water through warmth. To the second. 6. Let the burning glass also be tried with a heat that does not emit rays or light, as that of iron or stone heated but not ignited, boiling water, and the like, and observe whether there ensue an increase of the heat, as in the case of the sun's rays. To the second. 7. Let a burning glass also be tried with common flame. To the second. 8. Comets, if we are to reckon these two among meteors, are not found to exert a constant or manifest effect in increasing the heat of the season, though it is observed that they are often followed by droughts. Moreover, bright beams and pillars and openings in the heavens appear more frequently in winter than in summertime, and chiefly during the intensest cold, but always accompanied by dry weather.
Lightning, however, and coruscations and thunder seldom occur in the winter, but about the time of great heat. Falling stars, as they are called, are commonly supposed to consist rather of some bright and lighted viscous substance than to be of any strong fiery nature. But on this point let further inquiry be made.
To the third. 9. There are certain coruscations which give light but do not burn, and they always come without thunder. To the fourth. Eructations and eruptions of flame are found no less in cold than in warm countries, as in Iceland and Greenland. In cold countries, too, the trees are in many cases more inflammable and more pitchy and resinous than in warm, as the fir, pine, and others. The situations, however, and the nature of the soil in which eruptions of this kind usually occur have not been carefully enough ascertained to enable us to subjoin a negative to this affirmative instance. To the fifth. 11. All flame is in all cases more or less warm, nor is there any negative to be subjoined. And yet they say that ignis faucis, which it is called, which sometimes even settles on a wall, has not much heat, perhaps as much as a flame of spirit of wine, which is mild and soft. But still milder must the flame be which, according to certain grave and trustworthy histories, have been seen shining about the head and locks of boys and girls, without at all burning the hair, but softly playing around it. It is also most certain that about a horse, when sweating on the road, there is sometimes seen at night, and in clear weather, a sort of luminous appearance without any manifest heat. And it is a well-known fact, and looked upon as a sort of miracle, that a few years ago a girl's stomacher, on being slightly shaken or rubbed, emitted sparks, which was caused perhaps by some alum or salts used in the dye, that stood somewhat thick and formed a crust, and were broken by the friction. It is also most certain that all sugar, whether refined or raw, provided only it be somewhat hard, sparkles when broken, or scraped with a knife in the dark. In like manner, sea and salt water is sometimes found to sparkle by night, when struck violently by oars, and in storms too, at night time. The foam of the sea when violently agitated emits sparks, and this sparkling the Spaniards call sea lung. With regard to the heat of the flame, which was called by ancient sailors Castor and Pollux, and by moderns St. Elmo's fire, no sufficient investigation thereof has been made. To the 6. 12. Every body ignited so as to turn to a fiery red, even if unaccompanied by flame, is always hot. Neither is there any negative to be subjoined to this affirmative, but that which comes nearest seems to be rotten wood, which shines by night, and yet is not found to be hot, and the putrefying scales of fish, which also shine in the dark, and yet are not warm to the touch. Nor again is the body of the glowworm, or the fly called luciola, found to be warm to the touch. To the 7th. 13. In what situation and kind of soil warm baths usually spring has not been sufficiently examined, and therefore no negative is subjoined. To the 8th. 14. To warm liquids I subjoin the negative instance of liquid itself in its natural state. For we find no tangible liquid which is warm in its own nature and remains so constantly, but the warmth is of an adventitious nature, superinduced only for the time being, so that the liquids which in power and operation are hottest, as spirit of wine, chemical oil of spices, oil of vitriol and sulfur, and the like, which burn after a while, are at first cold to the touch. The water of natural warm baths, on the other hand, if received into a vessel and separated from its springs, cools just like water that has been heated on a fire. But it is true that oily substances are less cold to the touch than watery, oil being less cold than water, and silk than linen. But this belongs to the table of degrees of cold. To the 9th. 15. In like manner to hot vapor I subjoin as a negative the nature of vapor itself, such as we find it with us. For exhalations from oily substances, though easily inflammable, are yet not found to be warm unless newly exhaled from the warm body. To the 10th. 16. In like manner I subjoin as a negative to hot air the nature of air itself. For we do not find here any air that is warm, unless it has either been confined or compressed, or manifestly warmed by the sun, fire, or some other warm substance. To the 11th. 17. I here subjoin the negative of colder weather than is suitable to the season of the year, which we find occurs during east and north winds, just as we have weather of the opposite kind with the south and west winds. So a tendency to rain, especially in winter time, accompanies warm weather, while frost accompanies cold. To the 12th. 18. Here I subjoin the negative of air confined in caverns during the summer, but the subject of air in confinement should by all means be more diligently examined. For in the first place it may well be a matter of doubt what is the nature of air in itself with regard to heat and cold. For air manifestly receives warmth from the influence of the heavenly bodies, and cold perhaps from the exhalations of the earth, and again in the middle region of air, as it is called, from cold vapors and snow, so that no opinion can be formed as to the nature of air from the examination of air that is at large and exposed. But a truer judgment might be made by examining it when confined. It is, however, necessary for the air to be confined in a vessel of such material as will not itself communicate warmth or cold to the air by its own nature, nor readily admit the influence of the outer atmosphere. Let the experiment therefore be made in an earthen jar wrapped round with many folds of leather to protect it from the outward air, and let the vessel remain tightly closed for 3 or 4 days. Then open the vessel and test the degree of heat or cold by applying either the hand or a graduated glass. To the 13th. 19. In like manner, a doubt suggests itself whether the warmth in wool, skins, feathers, and the like proceeds from a faint degree of heat inherent in them, as being excretions from animals, or from a certain fat and oilness which is of a nature akin to warmth, or simply, as surmised from the preceding article, from the confinement and separation of the air. For all air that is cut off from connection with the outer air seems to have some warmth. Try the experiment therefore with fibrous substances made of linen, not of wool, feathers, or silk, which are excretions from animals. It should also be observed that all powders, in which there is manifestly air enclosed, are less cold than the whole substance they are made from, as like, I suppose, that all froth, as that which contains air, is less cold than the liquor it comes from. To the 14th, 20. To this no negative is subjoined, for there is nothing found among us, either tangible or spirituous, which does not contract warmth when put near fire. There is this difference, however, that some substances contract warmth more quickly, as air, oil, and water, others more slowly, like stone and metal, but this belongs to the table of degrees.
To the 15th, 21. To this instance I subjoin no negative, except that I would have it well observed that sparks are produced from flint and steel, or any other hard substance, only when certain minute particles are struck off from the substance of the stone or metal, and that the attrition of the air does not of itself ever produce sparks, as is commonly supposed, and the sparks themselves, too, owing to the weight of the ignited body, tend rather downwards than upwards, and on going out become a tangible sooty substance.
To the 16th, 22. There is no negative, I think, to be subjoined to this instance, for we find among us no tangible body which does not manifestly gain warmth by attrition, insomuch that the ancient fancied that the heavenly bodies had no other means of power of producing warmth than by the attrition of the air in their rapid and hurried revolution. But on this subject we must further inquire, whether bodies discharged from engines, as balls from cannons, do not acquire some degree of heat from the very percussion, so as to be found somewhat warm when they fall. Air in motion, however, rather chills than warms, as appears from wind, bellows, and blowing with the mouth contracted. But motion of this kind is not so rapid as to excite heat, and is the motion of a mass, and not of particles, so that it is no wonder if it does not generate heat. To the 17th, 23. On this instance should be made more diligent inquiry. For herbs and vegetables, when green and moist, seem to contain some latent heat, though so slight that it is not perceptible to the touch when they are single, but only when they are collected and shut up together, so that their spirits may not breathe out into the air, but may mutually cherish each other, whereupon there arises a palpable heat, and sometimes flame in suitable matter. To the 18th, 24. On this instance too should be made more diligent inquiry. For quicklime sprinkled with water seems to contract heat either by the concentration of heat before dispersed, as in the above-mentioned case of confined herbs, or because the igneous spirit is irritated and exasperated by the water, so as to cause a conflict and reaction. Which of these two is the real cause will more readily appear if oil be poured on instead of water. For oil will serve equally well with water to concentrate the enclosed spirit, but not to irritate it. We should also extend the experiment both by employing the ashes and rusts of different bodies, and by pouring in different liquids.
To the 19th, 25. To this instance is subjoined the negative of other materials which are softer and more fusible. For gold leaf dissolved by aqua regia gives no heat to the touch, no more does lead dissolved in aqua fortis. Neither again does quicksilver, as I remember. But silver itself does, and copper too, as I remember. Tin still more manifestly, and most of all iron and steel, which not only excite a strong heat in dissolution, but also a violent ebullition. It appears, therefore, that the heat is produced by conflict, the strong waters penetrating, digging into, and tearing asunder the parts of the substance, while the substance itself resists. But where the substances yield more easily, there is hardly any heat excited.
To the 20th. 26. To the heat of animals no negative is subjoined, except that of insects, as above mentioned, on account of their small size. For in fishes, as compared with land animals, it is rather a low degree than an absence of heat that is noted. But in vegetables and plants there is no degree of heat perceptible to the touch, either in their exudations or in their pith when freshly exposed. In animals, however, is found a great diversity of heat, both in their parts, there being different degrees of heat about the heart, in the brain, and on the skin, and in their accident, as violent exercise and fevers. To the 21st. 27. To this instance it is hard to subjoin a negative. Indeed, the excrements of animals, when no longer fresh, have manifestly a potential heat, as is seen in the enriching of soil.
To the 24th. 28. Liquids, whether waters or oils, which possess a great and intense acridity, act like heat in tearing asunder bodies and burning them after some time. Yet to the touch they are not hot at first.
But their operation is relative and according to the porosity of the body to which they are applied. For aqua regia dissolves gold but not silver. Aqua fortis, on the contrary, dissolves silver but not gold. Neither dissolves glass, and so on with others. To the 22nd and 23rd. 29. Let trial be made of spirit of wine on wood, and also on butter, wax, or pitch, and observe whether by its heat in any degree melts them. For the 24th instance exhibits a power in it that resembles heat in producing incrustation. In like manner, therefore, try its power in producing liquefaction. Let trial also be made with a graduated or calendar glass, hollow at the top, pouring into the hollow spirit of wine well rectified. Cover it up that the spirit may better retain its heat, and observe whether by its heat it makes the water sink.
To the 25th. 30. Spices and acrid herbs strike hot on the palate, and much hotter on the stomach. Observe, therefore, on what other substances they produce the effects of heat. Sailors tell us that when large parcels and masses of spices are, after being long kept closed, suddenly opened, those who first stir and take them out run the risk of fever and inflammation. It can also be tried whether such spices and herbs, when pounded, would not dry bacon and meat hung over them, as smoke does.
To the 26th. 31. There is an acridity or pungency both in cold things, as vinegar and oil of vitriol, and in hot, as oil and marjoram, and the like. Both alike, therefore, cause pain in animate substances, and tear asunder and consume the parts in such as are inanimate. To this instance, again, there is no negative subjoined. Moreover, we find no pain in animals, save with a certain sensation of heat. To the 27th. 32. There are many actions common both to heat and cold, though in a very different manner. For boys find that snow after a while seems to burn their hands, and cold preserves the meat from putrefaction, no less than fire. And heat contracts bodies, which cold does also. But these and similar instances may more conveniently be referred to the inquiry concerning cold. End of Aphorisms 11 to 12 of Book 2. Recorded by Craig Campbell in Appleton, Wisconsin in 2009.